Hello students, this is Shachi. Welcome to my channel Crack Chemistry. Today's topic, chemical reactions and equations, part 3 is for class 10. For part 1 and part 2, please check the I button. Link of part 1 and part 2 has been given in description box. Students, before starting, I want to remind you to subscribe my channel for getting information about further important uploads, and press the like button if you like this video, and share this video with your friends also. Now let's start the topic. So first of all, we will see what are the topics which we are going to cover today. Today we are going to learn chemical equation, reactants, products, skeletal equation, balanced chemical equation. Then we will learn why a chemical equation should be balanced. Then finally we will learn steps for balancing a chemical equation. And one very important point, that NCERT problems with solutions will be discussed in part 4. So don't forget to watch part 4. We will start our discussion with chemical equation. First of all, we will see what is a chemical equation. Students, chemical equation represents a chemical reaction by using symbols and formulae of reactants and products. It means any chemical reaction can be represented by means of chemical equation by using symbols and formulae of reactants and products. So now we will see what are reactants. Students, reactants are those substances which take part in a chemical reaction. Reactants are written towards left-hand side of the arrow. And if more than one reactants are present, a plus sign is used between them. Now we will see what are products. Products are those substances which are formed during a chemical reaction. Products are written towards right-hand side of the arrow. And if more than one products are present, a plus sign is used between them. Now we will learn what is a skeletal equation. Students, an unbalanced chemical equation is called as skeletal equation. For example, consider the burning of magnesium ribbon in the presence of air. Students, magnesium on burning with air. Students, magnesium on burning in presence of air reacts with oxygen of air and form a white colored powdery substance, magnesium oxide. This activity I have discussed in detail in part 1. Now let's check the number of atoms of each element in reactant and product side. We will start with magnesium atom. In reactant side, only one magnesium atom is present. Similarly, if you look at the product side, you can find that in the product side also one atom of magnesium is present. Now, consider oxygen atom. You can see that in the reactant side we have one molecule of oxygen. One molecule of oxygen means we have two atoms of oxygen. Now, check the number of oxygen atoms in the product side. You can see that in the product side, we have only one atom of magnesium. So students, you can see that as the number of atoms of elements are not equal in reactant and product side. Therefore, this is an example of a skeletal equation. Now we will see what is a balanced chemical equation. A balanced chemical equation is that reaction in which number of atoms of each element is same in reactant side as well as in the product side. For example, we will consider the burning of magnesium ribbon again. Students, in part 1 you have seen that when magnesium ribbon is allowed to burn in air, After cleaning with sandpaper, it burns with a white dazzling flame. Now count the number of atoms of each element in reactant side as well as in product side. We will start with magnesium. Students, you can see that in the reactant side we have 2 atoms of magnesium. Now count the number of magnesium atom in product side. You can see that in product side also we have 2 atoms of magnesium. Now check the oxygen atom. Students, in reactant side we have 2 atoms of oxygen, and in the product side also we have 2 atoms of oxygen. So as the number of atoms of each element is equal in reactant side as well as in product side, this is an example of a balanced chemical equation. Now we will see why a chemical reaction must be balanced. Students, this is your NCERT question also. A reaction must be balanced in accordance to the law of conservation of mass. You have studied law of conservation of mass in class 9, according to which mass can neither be created nor destroyed in a chemical reaction. So if mass can neither be created nor destroyed in a chemical reaction, it means the number of atoms of each element remains same before and after a chemical reaction. Hence, it is must for us to balance a skeletal chemical equation. I hope this point is clear to you. Now we will learn balancing of a chemical equation. Students, consider the following word equation. Zinc reacts with sulfuric acid and forms zinc sulfate and hydrogen gas. This activity also we have discussed in part 1 in detail. So this is the word equation. Now I will write this word equation in the form of a chemical reaction by using the symbols and formula of reactants and products. So in this case you can see that we have 2 reactants. One is zinc. Symbol of zinc is Zn. And we have sulfuric acid. Formula of sulfuric acid is H2SO4. They react together and form zinc sulfate. Formula of zinc sulfate is ZnSO4 plus hydrogen gas is liberated. The formula of hydrogen gas is H2. So the above word equation we have written in the form of a chemical equation. Now we will examine the number of atoms of different elements on both sides of the arrow. Students, you can see that only 1 atom of zinc is present in reactant side. So I am writing here number of atoms of zinc in reactant is 1 in Zn. Now in product side also you can see that only 1 atom of zinc is present in ZnSO4. Now consider hydrogen atom. Students, in reactant side we have 2 atoms of hydrogen in H2SO4. Now look at the product side. In product side also you have 2 atoms of hydrogen in H2. Now consider sulfur atom. Students, you can see that in the reactant side you have only 1 atom of sulfur in H2SO4. Now look at the product side. In product side also you have only 1 atom of sulfur in ZnSO4. Now the last atom is oxygen. You can see that 4 atoms of oxygen are present in the reactant side in H2SO4. Now look at the product side. In product side also you can see that 4 atoms of oxygen are present in ZnSO4. As the number of atoms of each element in reactant side and product side are same, this reaction is a balanced chemical reaction. So we can conclude that as the number of atoms of each element is same on both sides of the arrow, above equation is a balanced chemical equation. Now let us try to balance the following chemical equation. Chemical equation is Fe plus H2O is equal to Fe3O4 plus H2. So step 1 is that to balance a chemical equation, first draw boxes around each formula. You can see that we have drawn boxes around each formula. And remember one point, that do not change anything inside the boxes while balancing the equation. So we have drawn boxes around each formula. This was step 1. Now in step 2, list the number of atoms of different elements present in the unbalanced equation. So we will start with iron. Students, you can check that in the reactant side we have only one atom of iron in Fe. You can see that in product side we have 3 atoms of iron in Fe3O4. Now look at hydrogen atom. Students, in reactant side we have 2 atoms of hydrogen in H2O. And in the product side also we have 2 atoms of hydrogen in H2. Now look at the oxygen. Students, in reactant side we have only 1 atom of oxygen in H2O. Now look at the product side. Students, in product side you have 4 atoms of oxygen in Fe3O4. So you can see that as the number of atoms of each element in reactant side and product side are not same, this is an unbalanced chemical equation. Now step 3. Students, for balancing a chemical reaction, it is convenient to start balancing with a compound which contains maximum number of atoms. So you can see here that Fe3O4 in the product side contains maximum number of atoms. It consists of 3 atoms of iron and 4 atoms of oxygen. The compound which we are selecting may be from reactant side or may be from product side. Now we have selected Fe3O4 for balancing. Now we will start balancing from Fe3O4 first. One more point is that in Fe3O4 we will select that element which has the maximum number of atoms. So you can see that it has 4 oxygen atoms and 3 iron atoms. So therefore, as number of oxygen atoms are more, we will start balancing with oxygen atoms. So we have selected Fe3O4 and in Fe3O4 we have selected oxygen atom. So we will start balancing with oxygen atom. For balancing oxygen atom, let's count the number of oxygen atom in reactant side as well as in product side. Initially we have only 1 atom of oxygen in H2O. Now look at the product side. In product side we have 4 atoms of oxygen in Fe3O4. So in reactant side we have 1 atom of oxygen in H2O. And in the product side we have 4 atoms of oxygen in Fe3O4. So to balance, what we have to do? We have to multiply H2O by the number 4 in reactant side. So let's see. We are multiplying H2O by 4. So now the partly balanced equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Now at this stage I want to explain you that why we have drawn boxes around each element and compound. Students, as you are beginner at this stage, so the purpose of drawing a box around each element and compound was that you must know that you cannot write any number inside the box or towards the right side of the box. You can write only towards the left hand side of the box. For example, you were supposed to add 4 oxygen atom. So for adding 4 oxygen atom, you cannot change the formula of the compound or element. So you cannot add 4 oxygen atom by writing as H2O4. This is the wrong method. And you cannot write as H2O whole 4 also. This is also a wrong method. Initially you can draw boxes around the symbols of elements and compounds, but once you become confident, there's no need to draw boxes. You can balance the chemical reactions directly. Now next step. Iron and hydrogen atoms are still not balanced. You can pick up any of the element to proceed further. We are selecting hydrogen atom for balancing. For balancing hydrogen atoms, let's count the number of hydrogen atoms in reactant and product side. So students, now you can see that in reactant side we have 8 atoms of hydrogen initially. in the partly balanced equation. 8 atoms of hydrogen are present in 4H2O. I hope it is clear to you. Now look at the product side. In product side, you have only 2 atoms of hydrogen in H2. So what you have to do for balancing? For balancing, you will multiply hydrogen in the product side by the number 4. So I am writing here 4 into 2. And always remember, 4 you will write towards left hand side of the box. So we have multiplied this hydrogen by the number 4. Now the partly balanced equation becomes Fe plus 4H2O is equal to Fe3O4 plus 4H2. Now we will start balancing the third element, which is still not balanced. The only one element which is left to be balanced is iron. So we will balance iron. So count the number of iron atoms in reactant side as well as in product side. You can see initially that we have only one atom of iron in Fe. And in product side we have 3 atoms of iron in Fe3O4. What you have to do for balancing iron? Definitely at this stage you must be able to answer that. In reactant side we will multiply it by the number 3. So 3 into 1. And always remember this 3 you will write towards the left hand side of the box. So now your equation has become 3Fe plus 4H2O is equal to Fe3O4 plus 4H2. So now we will check whether this reaction is balanced or not by counting the number of atoms of each element in reactant side as well as in product side. So you can see that we have 3 atoms of iron in the reactant side, and in product side also we have 3 atoms of iron. Now look at hydrogen atoms. In reactant side we have 4 into 2 means 8 atoms of hydrogen. Similarly, in the product side also we have 4 into 2 means 8 atoms of hydrogen. Now look at the third element. In the reactant side we have 4 atoms of oxygen, and in the product side also we have 4 atoms of oxygen. So as the number of atoms of each element on both sides of equation are equal, this equation is now a balanced equation. I hope it is clear to you. This method of balancing chemical equation is called hit and trial method. This is called as hit and trial method because we are making trials to balance the equation by using the smallest whole number coefficient. Now next step is writing symbols of physical states. Students, carefully examine the above balance equation which we have balanced just now. Are you getting any information about the physical state of reactants and products? Definitely no. No information has been given in this equation about the physical state of reactants and products. To make a chemical equation more informative, the physical states of reactants and products are mentioned along with their chemical formulae. The gaseous state is represented by the notation small g. Liquid state is represented by the notation small l. Aqueous state is represented by the notation AQ, and solid state is represented by the notation small s. Students, the word aqueous is written if the reactant or product is present as a solution in water. So now the above balance equation can be written as 3Fe S plus 4H2O G is equal to Fe3O4 S plus 4H2G. So you can see here that symbol G is used with H2O, which indicates that in this reaction water is used in the form of steam. And one more point I would like to mention here. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Students, sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and below the arrow of the equation. For example, carbon monoxide gas when reacts with hydrogen gas, the product is methyl alcohol CH3OH in the liquid state. This reaction takes place at 340 atm pressure. So this 340 atm pressure is written above the arrow. Now look at the second reaction. You are well familiar with the second reaction, which takes place during photosynthesis. During photosynthesis, 6 molecules of CO2 reacts with 12 molecules of water to form 1 molecule of glucose, 6 molecules of oxygen and 6 molecules of water. This reaction takes place in the presence of sunlight, which is written above the arrow, and in the presence of chlorophyll, which is written below the arrow. So students, I hope this point is also clear to you. Now we will see the topics which we have covered today. We have learnt about chemical equation, reactants, products, skeletal equation, balanced chemical equation. Then we have learnt that why a chemical equation should be balanced, and in the last we have learnt steps for balancing a chemical equation. And remember one point, that NCERT problems with solutions will be discussed in part 4. So don't forget to watch part 4. Students, thank you so much for watching this video. I hope each and every point is clear to you. Please post your doubts in the comment box. Press the like button if you like this video and share this video with your friends. Don't forget to subscribe my channel. Thank you so much. Have a nice day.